Okay, so now we're on page 7 of your notes. We're talking about the terms to know. So cube root. First thing you need to know is that it's a math problem. It's just like saying multiplication. That's a math problem. It's telling you to do something with math. So the cube root is telling you to find a number that is multiplied by itself 3 times. So for example, the cube root of 27 equals 3 because 3 times 3 times 3 equals 27. So that's a math problem. So it's cube root. The index there is going to be 3. So cubed, what does that mean? It means to multiply. Actually, let's just say it means that the exponent is 3. Right? So if I said 3 cubed is 27 because 3 times 3 times 3 equals 27. All right, so index. Index is the small number in front of radical. And we'll talk about this here in a minute. Irrational, we've defined that. So irrational is any number whose decimal never ends and never repeats. It has to meet those 2 qualifications. Repeats. A perfect cube would represent the volume of a cube. Just like perfect square, we've talked about, represents the area of a square. Pythagorean theorem, it's a squared with the exponent of 2, but I don't know how to do that while I'm typing, so I'm just going to write a2. So it's a squared plus b squared equals c squared. I actually just used it last night figuring out how to assemble our deck that we're working on. Yay, math. Okay, so radical is the symbol. Radicand is number under symbol. Rational is any number that can be written as a ratio. Ratio is in the word rational, and ratio means fraction. All right, and then square root. Well, we've been talking about that. So square root is literally like, it's a math problem again, but it's a number that is multiplied by itself twice, aka the side length of a square. Right? So if I told you that the area is 81, what's the square root? What's the side length? The side length's 9 because 9 times 9 is 81. All right, so squared means to multiply, let's just say the exponent is 2. Right? So if I were to square 9, that means 9 times 9 is 81. All right, so anyways, we're going to scroll down to where it says perfect squares and square roots of perfect squares. So list out all the perfect squares between 0 and 225. So how am I going to list out all the perfect squares? Well, that means the area of the square. So what would be the first area? Well, let's imagine. If the side lengths are 1, that means it's 1 times 1. And 1 times 1 is 1. So there's a perfect square. What if the side lengths are 2? 2 times 2 is 4. 3 times 3 is 9. Oh, it's kind of cut off, but it's okay. 4 times 4 is 16. 5 times 5 is 25. And then we got 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. Where am I at? 10 times 10 is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared, we flip-flop them, is 196. We've already done this before. And then we're going to flip-flop. Oh, hang on. We're not flip-flopping anything, actually. But 15 times 15 is 225. All right, so let's go through these. So here I'm giving you the side length of the square, and I want to know the area. So 2 is the square root of what? Well, it's the side, and 2 times 2 is 4. So 4 is the perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, that area of the square would be 36. 7 times 7 would be 49. 12 times 12 is, ooh, which one was 12 times 12? 144. Uh-oh. It's not letting me type in another 4. Oh, I don't know what to tell you there. If you're writing it, you're in luck. 13 times 13 is 169. Man, it's not letting me type that either. That's my bad. 14 times 14 is 196. YOLO. I don't know. Find the area of a square. So that's what we just did. We found the area of squares if the side length is 10. Well, without a square, what would be the side length? So we would have to square the side. So that would be 10 times 10. And it's not working again. But in this first line, I would want 10 times 10, and 10 times 10 is 100. That makes me mad. 10 does equal 10. But this should be 10 times 10. Let's see if I can use this. Can I write with this? Let's go. Can I write? Ooh, 10. Nope, this is too much. I'm sorry, guys. But 10 times 10 is 10. All right, anyways, okay, so to undo it, to go backwards, so say I'm looking at the square root of 100. Well, the square root is the side length, so that would be 10. So the square root of 100 is 10. Whenever you see that radical symbol, that's asking you, well, what was the side length? Here's the area. What was the side length? Here's the side length. All right, so a perfect square. A perfect square is any number that could represent the area of a square, hence the name perfect square. The area of a square is side times side, or side squared, which I'm just going to put a 2 there. So side squared, and that 2 should be smaller and up above the s. You know how exponents work, but I don't know how to do it on the computer. So all perfect squares have rational sides, and rational means any number that represents a ratio. Oh, I didn't run out of room. All right, so scrolling down. So the inverse of squaring a number is taking the square root. I don't know why it's cut off. That's my bad. Okay, so then we got some blanks over here. Well, this means if I'm starting at 144 and I'm getting to 12, well, what did I do? I took the square root, and that symbol tells me square root. All right, but then if I get to 12, or if I start at 12 and end up at 144, that means that I squared the number, which means I multiplied it by itself. So 12 times 12 is 144. So we're going to type in, maybe we're not going to type. I don't know why it's not working. Oh, there it goes. I just had to freak out on it. Squared. Squidward. Okay, so radical. The radical is actually the symbol here. That almost looking division box kind of a thing, but it's got a little check mark in front. So radical is the symbol. The radicand is the number underneath. So my radicand here is going to be 36. And then the index. Sometimes you don't see an index. So what is it? Your index is always going to be 2 if you don't see an index. So that means we're taking the square root. If you see an index of 3, that means you're taking the cube root. You're trying to figure out which number multiplied by itself 3 times gave me 36. But here it's just asking me what number multiplied by itself 2 times gives me 36, and that would be 6. All right, so remember the big number is the perfect square, and the square root, think about roots being really skinny and small underground. So the square root is the small number. So if I ask you about 36 and 6, 36 is going to be the perfect square because it's the area of the square. And then square root would be 6, the small number. All right, so scrolling down, it says find the square root of all perfect squares. If impossible, write irrational because we cannot find the square root of non-perfect squares. 121. Is that one of my numbers up here? Why, yes, it is. So what is the square root of 121? Meaning what would be the side length of an area of a square that has 121? And that's going to be 11. 24. Is that number up here? Nope, it ain't. No number multiplied by itself is going to give me 24, so we're saying irrational. I'm just abbreviating. 225. It's going to be 15. Oh, 15. The square root of 1, what multiplied by itself gives me 1, and that's 1 times 1 equals 1. Anything multiplied by itself going to give me 2? Nope, so that's irrational. Square root of 81, 9. My computer hates me. Square root of 36, 6. Square root of 20, irrational. What if I told you that some of these had 2 answers? Would you freak out on me? Well, let's look at this first. So moving on to page 8, find the square root of each number. Square root of 25 is 5. Can I find, look, see how there's an index there? What number multiplied by itself is going to give me 144? Trick question, there is no number, so it's irrational. Square root of 1, 1. Square root of 16 is 4. So now we have the negative sign out in front. What does that mean? Well, this is what I was talking about. Every single answer or every single square root problem has 2 answers. Because it's not just 5 times 5 equals 25, but it could also be negative 5 because negative times a negative is a positive, and negative 5 times negative 5 is positive 25. So this could also be not just 1, but negative 1 because negative 1 times negative 1 equals 1. I don't know where that went. So this could also be 4 or negative 4. I don't know why they keep disappearing. It makes me sad. So what I'm going to do is plus minus 4. That means it could be either. And how about I do this? Plus minus 1. Come on, computer. Come on. You can do it. You smart. Whatever. It's not smart. I lied. Okay, but then we get down here to where it says the negative square root of 64. This means that they just want the negative answer of it. So they're telling you, I get it, that the square root of 64 could be 8 or negative 8, but I just want negative 8 as the answer. When they say plus or minus, that means they want both answers. So we can also answer as plus minus, what is that, 7? So the only time that you really have to worry about writing both positive and negative answers is when it has that plus and minus in front. If it just has the negative, they want the negative. If you don't see anything, we're assuming that they just want the positive number. But then look at this one. How is this different than that? Look at where the negative sign is. If there's a negative underneath the radical, we cannot solve it because there's no number multiplied by itself that's going to give me a negative 25. Think about it. 5 times 5 is positive 25. Negative 5 times negative 5 is still positive 25. So this is going to be no solution or no real numbers. So it's just letting me type no. There it is. All right, so number 1, let's try this. What is the difference in having an index of 2 or no index at all? No difference. I'm about to run out of time. Does it matter where the negative sign is when solving a square root? Yes, it must be in front of radical. And then you guys answer 3 and 4. You try that for yourselves.